This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. I look at this and I ask myself, is there anything that I can strip away as n becomes really big? Well, if n becomes really big, this here is going to overpower, and you can test it. Let's say n is equal to 1. 2 to the 1 versus square root of 1. So these here are your n's. This is just 2 and this is just 1. So which one's always bigger? This one, the 2 to the n. So I can strip this away. That means that I'm able to find a b of n, a sequence that I can compare to. So I would want to do a comparison test. And I personally always tried direct comparison test first. So what is the rule? Well, if your sequence, your given sequence, which is this one, a of n, is less than or equal to b of n, and the series b of n converges, then your series a of n will also converge. If you have trouble memorizing these rules, you can check out my video at Sarai Studies for the direct comparison test on how to remember it. It's in the CALC 2 class under infinite series. And so then we would just do the opposite signs, diverges, and then everything else just drops down. So the comparison test is IBBCC. First step is information, the information that we know and the information that we want. The information that we know is always our given sequence, 1 over 2 to the n plus square root of n. The information that we need is always going to be our b of n. What sequence are we comparing to? And that brings us to, well, find b of n. That's this b right here. How do we do that? We say to ourselves at large n, and then we take our sequence a of n. So as n goes to infinity, this becomes what? Well, again, as you plug in infinity, we already said that this is going to overpower, so it's going to end up being 1 over 2 to the n, and that is our b of n. So 1 over 2 to the n. Beautiful. Now we have everything we need. We have our a of n and our b of n. Now we have to find the behavior b of n, and we also have to compare a of n and b of n. I do this first. So then the next b is, how does the series b of n behave? Not the sequence b of n, the series. Whatever you see here, you're going to copy down here, and then you're going to take your b of n, and all you're going to do is find if it converges or diverges, and it's always going to either be p-test or geometric test that you're going to use here. So here I can see that I can rewrite this as 1/2 to the n, and so this is in geometric form. So the way that I remember the geometric test is I like calc more than I do geometry. So geometry, I like calc more. So converges, and then it has to do with the absolute value of r, and then there's always a 1 there. And then the opposite is true. Diverges 1, and then opposite, and then this is the same. So those are the rules. And so your r is always this. So r is equal to 1/2. Absolute value of r is still equal to 1/2. That's less than 1 because you're taking 1 and dividing it, so you're making it smaller, so it's going to be smaller than 1. So because the absolute value of r is less than 1, this series converges. So we hope that when we compare a of n and b of n, that a of n is less than b of n, because then we can say that if this is true and this is true, then we can say that our series a of n converges. And that's our next step, comparing. So what do? We're going to take our a of n, then we're going to take our b of n, we're going to put a circle in the middle, and then the numerators are the same. So the only thing you're comparing are really the denominators. So here I see 2 to the n, here I see 2 to the n. So essentially they're the same, right? But then this denominator has 2 to the n plus something more. So this denominator is going to be bigger, meaning that on both sides you have the same thing, but you're dividing it here more, meaning that same thing is going to be smaller. So it is true that this is smaller, so our a of n is less than our b of n, and that's exactly what we have here, and then boom, beautiful. Now because a of n is less than b of n, and our series b of n converges, then we can say that our original given series a of n will also converge. And that is our conclusion part. So I always start with since, and then I just go in the order that I did my things. So step 3 and then step 4. I literally just copy the sentence that I wrote, and then I literally just copy this. And to be specific, it's 0 right here because direct comparison tests and comparison tests only work with series where their terms are greater than 0 or eventually positive. And then we say for all n is greater than or equal to 0, so whatever number is here, then direct comparison test implies that our series converges. And that's it for this video. I'll see you in the next.